The next model that we're going to look at is the Arima 022 model, and it does something that from a conceptual standpoint makes a lot of sense. Why don't you use exponential smoothing to track the level of the process and to track the trend of the process? In other words, you sort of got two exponential smoothing models working in conjunction. So at the bottom of this list of models that we've looked at, we will add the Arima 022 model, and you notice it does have a common name. It is called the Holt-Winters model, Holt-Winters, I guess it should be. It's also called double exponential smoothing, and this model does get used quite frequently, and at the same time there's probably not a lot of people who use it that understand it very well. So you will have the advantage of being aware of the model, being able to use it, and to know what's going on inside the model. And by knowing what's going on inside the model, I mean understanding the verbal description of the model and being able to code the model into an Excel spreadsheet. So in the red there, we're showing the Arima 022 model is like the other trend models we've looked at. It has a level and a slope, or I'm using slope and trend interchangeably. And in this case, both the level and the slope are estimated using exponential smoothing. And looking at our Arima PDQ terminology, the D equal 2 in the middle tells us that both the trend and the level of the process will change or adapt over time. And then the third parameter, the 2 for D, tells us that there will be two types of exponential smoothing going on, one for the level of the process and another one for the trend in the process. So before we get into a lot of fancy formulas, I'm going to walk you through an example. So this is the data that we looked at before, and we got to initialize or get started. This so for time period 2, we will set the level of the process as the observed value for time period 2. And for time period 2, we will initialize the slope as the difference between time period 2 and the previous time period. So now we have initialized values for the slope and the level, and we'll use our exponential smoothing logic to update those as we work through the data. If you were using exponential smoothing to update the level and the slope, it would be logical to say, well, we just have two exponential smoothing models. One's tracking the level of the process, just like we do in regular exponential smoothing, and the other one's tracking the slope of the process, and then we just add those two numbers together to get the forecast. The Arima 022 model actually goes a little bit beyond that. It says the information we have about the slope and the information we have about the level should be used in combination when we're updating our parameters, our level and our slope. So here's the first example of how you'll see that play out. The new level is the weighted average of the most recent observation, which makes sense, and the previous forecast. In other words, that forecast includes the information that we had from the trend. So it basically says, this is what we observed this period, and this is what we forecasted we would observe this period, and we're going to weight those two together. And that takes advantage of both the information you have about the level and the slope of the process. Sounds confusing. I'll play that out a little more in detail on the next slide. We have just observed the sales for period 3, and we want to update the level of the process. So the level 3 will be a weighted average that will include the current sales So we're showing here that 2009 goes into that, and there will be an alpha that by which that gets weighted. This is very similar to regular exponential smoothing models. And then we will weight by 1 minus alpha the forecast that we made in the previous period. That forecast will include both the level and the trend of the previous period. So we're basically saying this is where we would expect the process to be in this period given the level and the trend that we had estimated before. And we're going to include that in our update of our new level. And then alpha times the current sales plus 1 minus alpha times the old forecast gives us the new level of the process. To update the slope, we're going to look at the current observation and what I estimated the level of the process to be in the last time period. And that's a little different than what we did before when we updated the slope just by looking at the most recent difference of the observations. That's going to be easier to see with an example. Let's suppose I'm in period 3 and have just observed sales of 2,009 units. The three numbers that I'm going to use to update the trend or to get a slope factor for period 3 are going to be the actual sales during this period, the estimated level of the previous period, and the estimated trend or slope of the previous period. To get my best guess of what slope I just observed, I'm going to take the current sales and subtract from that the previous level. And then I'm going to weight that and update the old estimate of the trend that I had in the previous period. So the first number in the formula there you see is just the sales that I observed in the current period. And from the sales of the current period, I'm going to subtract the level, estimated level of the previous period, and that's my best estimate of the slope that I just observed. And I'm going to weight that quantity by alpha. In this case, I'm using alpha of 0.22, and specifically we call it alpha 2. And then I'm going to weight by 1 minus alpha 2 times the previously estimated trend or slope for the process. That weighted average becomes my trend or my slope for time period 3. So now let's just walk through the mathematical formulas that we use for this model. First of all, the forecast is just a level plus a slope. And you get started in time period 2. You set the level equal to the observed value in time period 2, and you set the slope equal to the difference between the observed value in time period 2 and time period 1. And then after that, at each time period, you update the level by taking a weighted average of the current observation and the most recent forecast. Alpha 1 is the weight that you place on the current observation. 1 minus alpha is the weight that you place on the previous forecast. And alpha will be a parameter somewhere between 0 and 1. And you update the slope in each time period as a weighted average between the old slope and the best guess of the slope that you just observed. The slope that you just observed will be estimated as the current value of the process minus the estimated level of the process from the previous time period. And that gets weighted by alpha 2, and 1 minus alpha 2 is the weight that you place on your old slope. So updating your process involves using the current value, the previously estimated level of the process, and the estimated value of the slope from the previous time period. Here's an example all worked out. You won't have to remember the formulas. You can use the Word document that I provided you to get the formulas. And next time in class, you will be working out an example and building a spreadsheet like this. And the way you find the optimal value of alpha 1 and alpha 2 is to use solver, and you will minimize the mean squared error, and you will have two decision variables, alpha 1 and alpha 2. And here's an example of how you would use the model. Let's suppose it's the end of the data and we're in week 810, and we want to forecast what's going to happen in week 811. We just add together the estimated current level and the estimated current slope, and that's our forecast for the next period. And to get the predicted range of variation around that one period forecast, we just add plus or minus 3 standard errors. And to forecast L periods into the future, we just take the current level plus L times the current slope. And here is an example of what that looks like when L is equal to 10. We're forecasting what the sales will be in period 820. That's 10 periods into the future. So we take the current level and add 10 times the current estimated slope.